to do the Claisen condensation, we need an ester, and then let's put one with an ethyl group to the side of the carbonyl. Remember, we need a minimum of 2 H's, and the mechanism will show us how. So if we were trying to use this ester in a Claisen condensation, we would choose O-ethyl to be our alkoxide base to avoid saponification or transesterification. So the mechanism starts like this, where the base grabs the alpha proton to make an enolate. That's not very favorable at all, but enough of the molecules make the enolate that we can do some more chemistry. And of course, we'll generate ethanol. So once we have that enolate, the enolate is nucleophilic and it adds to a second portion of ester. I'm just going to bend that O-ethyl like so. So the alpha minus, it goes to the carbonyl carbon, and we push out onto oxygen. Let's bring that over here. Here's our enolate ester part. I'm just going to bend the methyl that way. Now we've connected to the carbonyl carbon and pushed out onto O. That still has an O-ethyl, and then regular ethyl as the R group. That's a tetrahedral intermediate. Remember that from substitution chemistry? Now the O minus is going to push back in to reform the strong carbonyl and kick out the O-ethyl as a leaving group. All of these steps are reversible. Just keep going with a forward arrow. What this does is it generates what looks like the final product of the Claisen. But now remember, we kicked out O-ethyl, and we're in a sea of ethoxide as well. That we have an H, the second alpha H from our original ester is between 2 carbonyls now, and it's more acidic than ever. And so what drives the reaction forward, especially through that unfavorable first step of the mechanism, is that this last step now is extremely favorable. The base that we kicked out or other alkoxide molecules immediately take that proton off in a full forward reaction. And it's like the Chatelier's principle, removing a product makes more of it. So then what we do is the molecule sits here in a very stable state in the enolate, if you're keeping track. That's now more sterically hindered. Okay, and it waits there until you add acid as a chemist. So the final step then would be to add some form of acid. Your book often shows acetic acid or sulfuric acid. H3O plus is how I typically would express that. But the last step would be that minus reprotonates. And again, this is the H3O plus is not there until you add it. And this will get us back to the final Claisen condensation product.